For today's notes, I have a highlighter, some paper to write with, and I have a few different colored markers. If you don't have different colored markers or pens or colored pencils, it's okay. I'm just using these to provide more of a visual. So this section of notes is from the part of your workbook called What Makes Up a Substance. So I'm going to write that at the top of my paper. And everyone is taking these notes today, whether you are in person or remote, and we'll be taking these notes on the 13th. So first, just some background information. Not all particles are the same. And as a few examples, we'll look at helium, carbon, oxygen, and water. The chemical formula for water is H2O. I'm going to write that on there too. One thing I didn't do was to underline the title of my notes, so I'm just going to take my highlighter and go back over the title of my notes. And now I'll start using my colored markers. For each of these particles, I'm going to try to use a different colored marker. So helium is a small pink circle in my notes. I'm going to draw carbon as a slightly larger circle. I'm using this kind of like yellowy orange color. Again, if you don't have markers or colored pencils, that's fine. Just try to draw the shapes. Oxygen is what's called a diatomic particle. So when oxygen is by itself, not bonding with anything else, there are actually two oxygen atoms that stick together. Helium is on its own and carbon is on its own, but oxygen is a diatomic particle, so it has two atoms. Then for water, we have one oxygen, but the 2 in front of the H tells us that we have 2 hydrogens. So it kind of looks like a Mickey Mouse. The blue is the hydrogen and the red is the oxygen. Since the oxygen is bonded with hydrogens, it doesn't have to have a second oxygen atom. So we said not all particles are the same. Continuing with that, each substance has a different amount of energy. So the first heading in your text for this section is matter and atoms. And I'm going to highlight or underline that. So we need to know that all matter is made of atoms. And the definition for atoms is it's a small particle that is the building block of all matter. Since that's a definition, I'm going to highlight that. And also we should note that atoms combine to make substances. For example, 2 hydrogen and 1 oxygen gives us water, which is H2O. But if I have 2 hydrogen and 2 oxygen, this gives me hydrogen peroxide. and the chemical formula for that is H2O2. So H2O is water, which is perfectly safe for us, but H2O2 is actually hazardous. This is what we use sometimes to clean out cuts, but it's actually pretty harmful to your skin cells. So just by adding that extra oxygen, it's a completely different substance, and it reacts or kind of does different things than the water. So there'll be more about that in a little bit. But the next heading in this section is substances, and we start with the definition of a substance. A substance is matter with a composition that is always the same. And I'm going to highlight my section title and that definition, or the keyword. So, for example, I use water a lot as an example, but if we have 2 hydrogen and 1 oxygen, this will always be water. And H2O2 will always be hydrogen peroxide. All substances have unique properties. So water has unique properties that are different than the properties of hydrogen peroxide. These unique properties might include boiling point, melting point, freezing point, whatever state it is at room temperature. We learn more about those, I think, in the next module, or maybe the module after that. This section of the text then goes into elements. The definition of an element is this is a substance made of only one type of atom. And we represent this by using colored circles. So by using circles of one color or colored circles, either way. Just going back and highlighting. So up at the top, these are elements here. I've used a pink circle to represent helium, orangey, yellowy circle to represent carbon, red circles to show oxygen, and then water is a combination of oxygen and hydrogen. So we used different colors for each of those elements. I have a little bit more space down here. Let's continue with information about elements. So some elements have been around for a long time. I mean, all of the elements have been around since Earth formed, but some elements have been known for a very long time. So let's write, scientists have known some for thousands of years. For thousands of years. These would be things like gold. The abbreviation for gold is AU. Also, copper. The abbreviation for copper is CU. For silver, the abbreviation is AG. So these abbreviations don't match up as nicely as like hydrogen and oxygen do. These elements have been known for so long that we actually use their Latin names. With other elements like oxygen, we can just use O. We'll learn more about why like copper is Cu, gold is Au. Why are those abbreviations used instead of just G, C, and S? I actually think we learn about those on Thursday and Friday of this week. So I've run out of room on this page, I'm just going to tear this sheet off and start on a new page. This new page also starts a new heading. This section of the text is compounds. And again, we start with a definition for compounds. A compound is made of atoms, and it has to have at least two different kinds. So atoms of two or more elements that are bonded together. Okay, and they have different properties. A compound has different properties than the elements it's made of. For example, water, yet again. So we have hydrogen plus oxygen equals water. So all of these are colorless and odorless. But one is a gas, actually two are a gas. So hydrogen and oxygen are gases, but water is a liquid. And this is all at room temperature. So then we get into element ratios. I'm going to go back and highlight compounds and the definition. For element ratios, compounds always have a fixed ratio. So water will always be a 2-to-1 ratio. If I had 4 hydrogen, in order to keep that 2-to-1 ratio, I'd have to have 4 hydrogen and 2 oxygen. Along this same idea, if I take the same elements but in different ratios, I would have an entirely different substance. So same elements, different ratios. Let's say this means it's a new substance. So this same elements, different ratios is actually a new heading in the text. But for example, nitrogen and oxygen can form 6 different compounds. So it was a bit rushed at the end there. This was my second attempt at the video, so that's why it was a little bit rushed. We're going to end the notes here, and then we'll pick up again during our next lesson.